Hello and welcome to this video about salts. We're going to look in this video at what neutralization reactions are, what salts are, and what an acid-base titration is. Neutralization, what does that word mean? Neutralization refers to a chemical reaction between an acid and a base, and it always forms water and a salt. Another way to think about it is an acid plus a base always gives us water and a salt. Here's an example of an acid-base reaction. Can you find the salt as in the products of this reaction? Well, you know this is water, so that's not the salts. NaCl, otherwise known as sodium chloride, that is the salt. What is a salt? Before we move on to that, let's just look at this compound right here. This is sodium bicarbonate. It's a base, and it is the primary ingredient in antacid tablets. And this base in the antacid tablets, it reacts in your stomach to neutralize the stomach acid. So back to the question, what is a salt anyway? Sodium chloride is not the only salt, but let's take a look at that to start with. A salt is any compound formed when the negative ions from an acid combine with the positive ions from a base. Let's start with the negative ions first. Let's look at our acid. Here's our acid. Remember, it's a proton donor, so this will be the acid. When this dissociates in water, it's going to form these ions, our proton ions and our negatively charged chloride ions. So when the negative ions from this acid, in other words, the chloride ions, combine with the positive ions from the base. Well, if hydrochloric acid is our acid, we can see that sodium hydroxide is our base. When it dissociates in water, it produces sodium and hydroxide ions. And when the salt forms, it's the positive ions from the base. So it would be these positive sodium ions. There they are. So those two combine and form our salt. That is the definition of a salt. Here are some common salts. These are actually really interesting. I wasn't able to put pictures in here to liven this up, but read through these. We just talked about sodium chloride. That's the common table salt. Sodium hydrogen carbonate is another one, often called sodium bicarbonate only, and it is baking soda. And you're aware of that being in antacids and different foods. Calcium carbonate is otherwise known as calcite, or sometimes chalk, and potassium nitrate, or saltpeter. Potassium carbonate is otherwise known as potash. You've probably heard of that before. And these are all important in manufacturing different products. Sodium phosphate is found in detergent. Ammonium chloride is found in dry cell batteries. So an acid-base titration is the last thing we're going to really focus on, and this is a process that can be really useful if we want to know what the concentration is of some unknown solution, an acid or a base. And the way we can set this up to determine how concentrated, how much acid or base is actually in maybe some product that you have. You'd like to test it and see if they're really telling the truth on the packaging. You can do that by setting up a titration where you have a burette, a glass burette here that will hold a certain volume, and it's graduated, so you can see how much volume you've used, that you've allowed to exit this burette at the bottom. There's a little stopcock here that you can turn to allow liquid to exit the burette, or put it in the stop position so that it is not exiting the burette. And we start with a solution that we're going to analyze, something we don't know what the concentration of it is. And we put the known quantity of it, measure out how much we want, in this flask right here. We also add some indicator to it. And the indicator is important because we would like to know at what point this is being neutralized. So we pick an indicator that is going to change color at when the neutralization happens at pH 7, right in the middle. so that when we get to our endpoint, we know it's the endpoint because our indicator has indicated that to us with a color change. In our burette, we fill our burette up with a solution that has a known concentration. So something that we have made or something that we are very certain that we know what the concentration is. Then we begin to add a little bit of this solution to our unknown solution, a little bit at a time. And you can see that sometimes it turns color because right there where we are having the neutralization occurring, it's going to change color, but overall, when we swirl this about, it will go back to its original color. When we reach the end point, the color will not go back. It will remain this color. If we overshoot the end point, it might get a really nice dark color. But we'd like to, just at the point where the color changes, we'd like to stop our reaction there. We can then read our burette. We can see how much we have used of this solution with a known concentration. And then we can calculate what the concentration is of this unknown solution. There are also other chemicals that can be used as indicators. We can use natural chemicals, natural indicators that can be extracted from cabbage, roses, and even radishes. If you want some extra advanced proficiency ideas, find out at what pH some of these natural indicators change color, and what colors do they change from and to. How would you go about extracting the indicator from these substances? Or maybe look into what Epsom salts are. Find the chemical formula, what it's used for, how it was named. Or maybe you could look at a specific titration and explain to me how that works. How would you actually go about calculating different concentrations? How might you use molarity involved in those calculations? Or maybe you have other ideas. Look forward to seeing what you come up with, and we'll see you in class.